More generally, and in maybe a more mathematically sophisticated notation, we can write our next now series like this. This is the case for any arithmetic series. Y sub n equals y sub n minus 1 plus d, where d is the common difference. All right, don't get too overwhelmed by all that notation. What it means is very simple, right? To find the nth term of an arithmetic sequence, which let's say it's your current term. Let's say it's the current term that you want to know. You just take the last term and add the common difference, right? Let's say we have this arithmetic sequence here, and let's say it starts with its first term, 13. Second term is 18. Third term is 28. No, sorry, third term is 23. Fourth term is 28, and third term is 33, right? So, sorry, first term 13, second term 18, third term 23, fourth term 28, fifth term 33. So what if we wanted to find its sixth term? Okay, well, using this notation here, that means we would want to find y sub 6, right? The sixth value. Well, we know that's equal to y sub n minus 1. In this case, that would be the previous term. So that would be y sub 5 plus the common difference. In this case, the common difference is 5, right? Look at the sequence and see that we're just adding 5 each time. And well, what is y sub 5? That's 33, right? And you see that's the value of this kind of notation, because if we know the previous value, it becomes very easy to calculate the next value, right? And similarly, what would y sub 7 be? It would be y sub 6, right? Plus the common difference again, 5, right? And well, what is y sub 6? We just figured it out, right? It's 38. So that's going to equal 38 plus 5, which is going to equal 43, right? And you will always be able to find the next term of your arithmetic sequence using this formula. And we can also write the same thing in function notation, right? Because doesn't it make sense that the value of the sequence is a function of which term in the sequence it is? Or rather, I should state, doesn't it make sense that the value of any given term in a sequence depends on which term it is, right? If we ask, well, what's the value of some random term in this series? Well, it depends, right? It depends on whether it's the first term, right? It depends on whether it's the second term. It depends on whether it's the third term, right? So we can consider this a function where n, or which term is it, whether it's the first term, second term, third term, or fourth term, which we represent as n, that can be the input, and of course the value of the term is the output. So we can write that as f of n equals f of n minus 1, which is the value of the previous term plus the common difference, right? So just like we did before, what's f of 6? F of 6 would be the value of the sixth term, and that would equal the value of the fifth term, 33, plus 5, which was 38, right? And what's f of 7? F of 7 is the value of the seventh term. That equals f of n minus 1, f of 6 in this case, plus the common difference, right? F of 6 is 38, common difference is 5, so f of 7 equals 38 plus 5, 43. And of course, we have a vocabulary word, or rather a vocabulary term, for these kinds of functions, or rather the way these functions are written. We can call them recursive functions, or recursive sequences. That's when you have a function or a sequence where you write it as the value of your current term as depending on the value of your last term, right? Because this is written, what's the value of the nth term? Well, it's the value of the nth minus 1 term plus d, right? Or writing it as a sequence where we write it as y sub n equals y sub n minus 1 plus d, right? A recursive sequence or a recursive function is one where it is written as depending on the value of the previous term.